Okay, so for this problem, we're just going to go and try A, B, C, and D until we find one that correctly models what we see up above. Now up above it says that t equals 0, the water begins pouring into an empty container. The container is either option A, B, C, or D. And the water pours into the container until it's full at a constant rate. The situation is modeled by a given graph where t is independent variable and the depth of the water in the container is the dependent variable. For which in the following containers would the graph be appropriate? Okay, let's go one by one. Now here's the thing. We are pouring water in at a constant rate. So if this is time and this is the depth of water, and if our rate is constant, this would produce a graph that looks something more like this. It'd be a linear graph that corresponds to the container for A, assuming that we are pouring at a constant rate. When we look at B, I believe B is going to be the correct answer. And this is because the diameter here, right? The width across, the diameter of the container decreases midway through this container, and then it increases again. So it's larger, and then it gets smaller, and then it gets larger again. And this behavior can be shown in the graph above. So we can see the graph is steep in the middle portions, so it's able to fill up the middle of this container at a much faster rate because the diameter is smaller, and then as the diameter begins to increase, then it begins to fill up the container at a much slower pace. Correct answer is B.